Alright, so today we'll be talking about inscribed angles, and there's a lot of inscribed angle examples here. Okay, so first off, what is an inscribed angle? An inscribed angle is an angle that is inscribed on the circle. So D is on the circle, so EDF is an inscribed angle. Now an intercepted arc is the arc that's trapped by the inscribed angle. Okay, now here's some cool relationships between those two. Alright, the measurement of angle, oops, let's actually type that non-angry letters. Measurement of angle EDF is equal to one half. 1/2 times arc EF. Okay, and that's the cool thing about this, is that, for example, if this was a measurement of 60 degrees, this one would be a measurement of 30 degrees. Okay? Alright, and so that's how this one works. And this is going to carry out this theme of taking half of something. Okay, now later on when we talk about secant lines and worrying about that stuff, we're going to do some different formulas, but you're basically taking half to get this, not the inscribed angle, but just the angle that's associated with the intercepted arc. Okay, some cool things to just work with. They actually go through proof of the bow tie theorem, which I showed you before. Okay, now if you know one side of, if for example, if your intercepted arc, okay, here's some really cool things. If your intercepted arc intercepts at the same points as the diameter, you will be working with a 90-degree angle, which is a right triangle, which makes sense because if you're intercepting at a diameter, that is half of the circle, which is 180 degrees. That's a semicircle. So that makes sense why that turns this into 90 degrees. Okay, so that always works no matter where you actually draw it. It's really cool. Alright, now some other cool things about this too, and this is also in the theorems, okay, is that these two angles, albeit they are not congruent, okay, they are supplementary. Okay, opposite angles are supplementary inside of a circle, or if they're inscribed. So this angle will be added up with this one. 3, 4. That's a lot of arcs. Okay. Alright, so those ones will be adding up to about 180 degrees. Okay, which makes sense because it has to work with it, but it's one of the more unique ones to where these opposite angles are definitely going to be supplementary. Okay. So opposite angles are supplementary. Okay. All right, now right here, let's say, for example, let's say I was to take D and I was to drag it along the circle to where F is, okay, and that would make DE intersect at F, so D would equal F. I would get an inscribed angle that looks like this. Okay, now here's the really cool thing, is that the formula still works the same no matter where you're at on the circle. You have to be on the circle on one of the 3 points, or you have to be on the 2 points just working with it. Now this angle, or this ray, can go off forever in whatever direction you want it to be. Alright, but basically the measure of angle KLM is equal to 1/2 times arc LNK, and that would be a major arc. Okay. All right. Now, some other stuff that we could also remember too is that this stuff on the other side plus LKN should add up to 360. Okay. All right. So as we work with this, you guys, it should get a whole lot easier as you work with these formulas. But just remember, inscribed angles are going to be half of the intercepted arcs. Okay, that will carry you through this portion. Okay, now later on we will actually look at ones where you do not have the interception or the actual angle on the circle. We'll look at it outside the circle. Okay, but if you notice, each one of these has the angle on the circle. So you will be able to find angle measurements. You'll be able to find working measurements from just this information. Okay, and these are going to be two of the biggest formulas you'll need from this actual chapter. Okay, this one is a very helpful postulate that you'll work with. Is it always used? Not always, but it's actually very useful to use, especially when you know you're dealing with one side of a triangle inside an inscribed triangle inside of a circle, and you know one side is diameter. You definitely know you're dealing with a right triangle. Okay, all right, that's it for working with inscribed angles. I'll talk to you later. Bye.